So we have 0.5 grams of sodium hydroxide. We add that to 100 milliliters of a buffer. That buffer has two parts, 0.5 molar nitrous acid and 0.5 molar sodium nitrite. There's no volume change. What's the final pH? And we got the pKa of 3.14. So we're going to use, since we have a buffer, we're eventually going to use this equation. But we've got to do a little work before we get to that point. So, a couple things. The sodium hydroxide will react with what part of the buffer?
Acid.
The acid part. So, let's write this reaction first. HNO2 plus the sodium hydroxide, or just OH minus, will go 100% to the right because the sodium hydroxide is a strong base, and we'll have H2O plus NO2 minus. Now we try to fill in the blanks a little bit, and HNO2, we're adding something to buffer, so we have to do stoichiometry first. HNO2 is 0.5 molar times 100 milliliters. That's going to be 500 millimoles. Oh no, 50. There we go. Okay, and then NO2 minus, again, 0.5 molar times 100 milliliters. That's 50 millimoles. Okay, the sodium hydroxide is a little bit more painful. It's 0.5 grams. I want to change that to moles. So 0.50 grams of sodium hydroxide times the molar mass of that. 40. Okay, and that turns out to be 0.013 moles, or 13 millimoles. Okay, so you subtract the smaller number. It's usually going to be whatever you added to the buffer, minus 13 plus 13. So this will be 63, this will be 0, and this will be 37, all in millimoles. Now I can go to the buffer equation, the Henderson-Hasselbalch that I had up above. So I'm going to say pH. So I did my stoichiometry. After stoichiometry, you'll be able to go to Henderson-Hasselbalch. pKa, I was given that number, it's 3.14. So write that, 3.14, plus the log of the base, which is 63, over the acid, which is 37. And let's see what they got for that. That's 3.37. And we'll just think about it for a moment, see if it makes sense. I had a buffer, I added a base, so I'm expecting the pH to go up from the pKa. The pKa initially was 3.14, and so it went up just a little bit to 3.37. So that makes sense because I had a base, so that number should go up. Yeah?
Just a general question. For the Henderson-Hasselbalch, like, can you use millimoles for the log part, or like molarity or whatever, as long as they're the same?
You can use, yeah. For here, as long as your units are the same, that's 1. It has to be a unit related to moles or molarity. So really, moles or molarity would work fine. And you need to make sure there's no funny volume issues. So in this case, it said you had 100 milliliters of the buffer and the volume stayed constant. So it's still going to be 100 when you're done. And so this would be divided by 100 if you want molarity, and this would be divided by 100 if you want molarity. So it's going to be the same thing.
Okay.
Yeah.
I have another question. For this Henderson-Hasselbalch, is it what you're solving for going to be base, either base or acid at the bottom?
At the
Like
bottom of what part? Here?
Oh, no. In the equation?
Yeah.
Yeah. When it says log like 63 over 37, when is it base or acid at the bottom? Or is it always
Always acid.
Oh.
Yeah, it doesn't matter what your buffer is, doesn't matter whatever, this is always pKa, this is always base over acid. There's another formula you can derive that is POH equals something like the pKb plus the acid or the base, but it's irrelevant because this one does the same thing. Yeah.
You said that the POH is pKb plus the log acid over base?
Something like that. I'd have to rederive it.
It's in the practice exam.
Yeah.
Oh, awesome.
Yeah.
Then there, derive it.
Base over acid is just minus.
Minus.
Yeah,
Oh,
pKb minus.
Well, if it's minus base over acid, that's the same as plus acid over
Yes.
base. Yeah, it's the same thing.
Oh.
Yeah, I remember that problem, right. Okay, anything else on this
I
one?
have a really quick question.
Yeah.
So you're assuming the 0.5 grams of NaOH and like you're plugging that into the hydroxide equation, so it's because it's also a base, because it's a strong base as well. Like how, I don't know, like
Okay, yeah,
is
well,
that basically how you figured out?
that's right. So this is here.
Yeah.
So this part was okay,
Yeah.
right?
Yeah.
This is the moles of NaOH.
Okay.
First of all, is that part okay?
Yeah.
Well, there's one hydroxide in every
NaOH is
NaOH.
spectator, right? Is
So-
it Na?
It's a spectator,
Yeah,
right?
Okay.
And what you would say in Chem 2A, there's 1 mole of hydroxides in every mole of sodium
Yeah.
hydroxide.
Okay. Okay.
Yeah, so that's why it's the same number.
Okay. Thank you.
Bye.
I'm on top.